Yes, student, good morning. We are going to see about the two different cache addressing models in this video. The first model is physical address cache. So, when the cache is associated with the cache memory, physical memory address, it is called as physical address cache. So, the example processors are VAX 8600, Intel i486. So, these two are the example processor which will come under the type of physical address cache. How the address is cached? Indexed means it is indexed with the help of physical address. How it is generated means it take the help from TLB. TLB is nothing but translation look aside buffer. It is a one address translation unit which present in the unit of MMU. MMU is nothing but memory management unit. Right? There are two types of caches in here. What are those means? Write through cache, another one is write back cache. So write through caches is nothing but your data will be immediately written to that cache. Right? So using the write through cache, the data is immediately written, which will be written. Right? Write back is one of the cache where it will be present means when any delay is occurred. So in case of page fault scenarios, this write back cache will be enabled. Right? So then write through requires more bus or network cycles to access the main memory, but WB allows the CPU to continue without waiting for the memory to cycle. Fine. So the diagram which shows the physical address cache, right? Physical address cache. So here how the diagram is drawn here means in the left hand CPU is nothing but processor. Then in the right hand main memory. So in between the processor and main memory, how this cache memory is addressed. How it uses the physical address means first in between the processor and cache there is a MMU unit. MMU unit is nothing but memory management unit. So from the CPU to MMU virtual address is referenced. So this virtual address is directly transferred in terms of physical address. So this physical address is given to cache. From the cache to main memory, the corresponding physical address is referenced. So from the respective physical address, the data will be retrieved. So in that way, this address is transferred and data is accessed. Right? So the data is accessed. This is the architecture of this physical address cache. How this execution is instruction is executed means how it is executing means in the down you have here one more diagram which shows the physical address translations. So from CPU to memory unit virtual address is given. So from memory unit to the first level of cache, that means D cache, data cache and instruction cache. This the cache unit is divided into two parts here. So data cache and instruction cache. Remaining and all same. So the physical address is given to the first level data cache with the help of physical address. From the first level of data cache D cache to second level D cache, the same PA is assigned. PA is nothing but physical address. From second level to main memory, the PA is assigned. So here the cache is divided into two levels of cache. Those are called as data cache and instruction cache. Right? So in the second type of addressing model is virtual cache, address cache. The virtual, how this cache is indexed means with the help of virtual address only. So example is i486. i486 is having both features. That means this Intel i486 processor is having both physical address cache model and also virtual address cache model. Right. How this virtual address cache model is designed means the same thing is repeated here. From CPU to main memory, first virtual address is given. From virtual address to this virtual address is directly given to the cache. From the cache, it is given to the main memory. There is a one more physical address is mapping. Physical address lines are there because it supports both cases. So that's what physical address lines are there. Similarly, virtual address lines are also embedded in this model I486 model, right? So this i486 model processor has the feature of both addressing physical address and also virtual address. That's what the separate line is introduced there in the first diagram. In the second diagram, it shows the detailed explanations of how the instructions are executing in this caches. Right here, I catch is there and also D catch is there. So D catch is having 8 kilobits of bytes memory, and I catch, instruction catch is having the capacity of 4 kilobytes. Right. So this unit IU is nothing but integer unit and FU is nothing but floating point unit. Right. From processor side, that means from processor both integer unit and floating point unit, the corresponding virtual address is mapped with the I catches and D catches. Okay, I catch and D catch, and also it is given to MMU for the further conversion of virtual addresses into physical address. So here the number shows the bit representation. Say for example, in the first I slashed with 64 denotes the 64 bit representation is used for denoting the virtual address from I catch to main memory. Right. So the line numbers represents the bit representation. So this is what happening in the virtual address models of cache memory. Right. I hope you understand this topic. I'll catch you in the next video about the next topic. Thank you.